to do with the oxidation states. So if I'm going to work out the oxidation state, let's say of chromium, right, I need to basically say there's going to be X, which is going to be the actual oxidation number. There's 2 chromiums there, right, and also in the case of oxygen, because that's also a part of the compound, that's going to be -2 because that's the charge of 1 oxygen times that by 7. So we'll always multiply the charge by the number of atoms, which is -14. So technically I have, in this case, if I want to work out the oxidation number, I've got 2x minus 14. And the reason why I was able to do this is because the chromium's within a compound. If it was just chromium by itself, right, plus something in an equation, that would just be 0. So in the case of that one, I need to equate that to the overall charge, right? So if it hasn't got a plus or minus charge there, then we just equate it to 0. But in that case, that's going to be -2. So we just need to calculate x. So x is equal to -2 plus 14. And then I need to divide the whole thing by 2 because it's 2x, okay? So I take everything to the other side. The answer is plus 12 divided by 2 is plus 6. So I took everything to the other side and made x the subject. The next one, it says I died. What that basically means, that I died because it ends in the I, that's the halide. So technically it's I-1 because that's in group 7. Can be used to oxidize iodide using the dichromate. So this is the dichromate. This is taken from the oxidation of the alcohols, where this is like an orange color, just to let you know. Right, and it goes into the green color when the alcohol oxidizes. It says deduce a half equation to show the oxidation of iodide into iodine. Okay, so I-1 into iodine. Iodine is I2. So remember that obviously when you've got a group 7, group 7s are always diatomic. Okay, so the ones that are diatomic are hydrogen, oxygen, nitrogen, and the group 7s. These are the only ones that you basically have to put as a 2. Okay, so these are the only ones that are diatomic there. Okay, so how you do it? First of all, you balance. So there's 2 atoms, 1 atom, 2. So you don't balance the charge, you're just balancing how many atoms there are. Okay, then you need to work out the overall charge. So you multiply the molar ratio by the charge. So 2 times -1 is -1. If there's nothing there, then that means that there's 0 if there's no plus or minus. So overall charge is 0. So you've got -1 overall charge, 0 overall charge. Then you need to add the electrons on the more positive side. So the more positive side is this side, and you need to add 1 electron like so. Okay, so you can write a 1 or you don't need to write a 1, it's up to you. But you need the 1 electron to balance that out. Okay, so that's fine there. The next one, it basically says deduce the half equation for the conversion of acidic. So when it says acidic basically means that you need a H+. That's what acidic means. And you want to convert this dichromate into the chromium. So let's do that. Let's do this question over here. All right. So basically you've got the Cr2O7 minus 2. Okay. Just need a bit more space. So we've got the Cr2O7 minus 2. Alright. Cr2O7 minus 2. And that's basically going to turn into Cr plus 3. Okay. So for this one, what you have is you have an unbalanced oxygen. Okay. So in the specification, right, you will always have an unbalanced oxygen. That's what the syllabus wants, right? So what you need to do is you need to put the water on the side where there's less oxygen, and on the other side you need to put the H+, which also provides acidic condition. So you always use the H+, H2O. So the H2O always goes on the side where there's less oxygen, and the H+ goes on the opposite side. Then what you need to do is you need to balance it. So you balance the chromium. Okay, so I always balance the atom first. That's not oxygen, hydrogen. Then I balance the oxygen. Then I balance the hydrogen. So if you do it in that particular order, then that will always work. So that's going to be a 14 there as well. Okay, so that's going to be 14. That's going to be a 14H plus there, because 7 times 2 is 14. Then I need to work out the overall charge. So let's work out the overall charge. So overall charge is multiplying just the molar ratio number by the charge. So here is 1 times -2, which is -2. That's going to be 14 times plus 1 plus 14. That's going to be, because there's two things there, I need to put the charges together, which is plus 12. 2 times plus 3 is plus 6. Water, there's nothing there, so is 0. So together is plus 6. And remember that the electrons always go on the positive side, so plus 12 is more positive than plus 6, and there's a difference of 2 electrons. So it's 6 electrons plus a Cr2O7 minus 2. You can see it's been reduced. Okay, so you can also see that's been reduced because it's gaining electrons, and it's also behaving as an oxidizing agent. And you can see how that turns into the plus 14 to make it acidic conditions, turning into the 2Cr plus 3. That's the green color, by the way, in the oxidation of the alcohols, plus 7 waters.